So now, how do we polarize unpolarized beams? So what happens is that originally, if you have non-polarized beams, they can oscillate into arbitrary directions. So all the unpolarized beams can be divided into two internal beams which are perpendicular to each other. So now if you put the filters, so when the polarization of the beam is random, but let's try to consider they are into these two perpendicular directions. One is parallel to the filters and the other one is perpendicular to the filters. So the component which is parallel to the direction of filter can passing through, and the direction which is perpendicular to the filter will be blocked. So this is how the unpolarized beams become polarized after passing through the polarizers, the filters. So actually, after passing through the every single polarizers, only 50% of the incident light will be transmitted. So which means only the half of the original wave will passing through. So the intensity will become weaker. And now if you put two polarizers arranged such that their polarization are parallel to each other, then the light still can passing through, and the intensity will not be decreased. So which means the intensity after passing through the second polarizers will still be the same. However, if the axes are perpendicular to each other, what will happen is that almost no light, as you can see here, can penetrate through the pair. So this one originally is parallel, now it becomes perpendicular. So if you put these two parallel, then the final answer is no light can be transmitted through. So now you understand what is a polarization means and how does the unpolarized beam become polarized by using the filters. Now let's have another conceptual quiz here. So this will be the first one unanswered conceptual quiz. So I will put two at least conceptual quiz unanswered today. So the polarization occurs for the wave that are for which one? So if you know the answers, please email me your answers with explanations through the email today. Now let's try to study the chapter 12. So we just finished the discussion of the chapter 11. So in the chapter 12, we are going to study about the atoms and the periodical table. So I keep mentioning about the molecules and the atoms, all these words, without defining what they are. So today I'm going to spend a certain amount of time trying to define every word I'm going to use regularly, so such that you will know what is atom means, what is a periodical table. So first, we are going to study what is the atoms, then what is the element. Then we are going to study different kind of examples, protons, neutrons, and if we have time, we are going to study the periodical table. So first, what are the atoms? So it may be very hard for people to understand, but based on the reading assignment I give you, you must have learned that our body is made of the dust of the stars. So our body is new, but the atoms our body is made of is pretty ancient. They are probably made 1 million years ago or even longer. So the second thing is that the structure of atoms. Atom actually is a very empty structure. In most of the space, it is empty. So most of the mass was centered at the so-called nucleus, which is the center of the atoms. And the center of the nucleus is made of the neutrons and protons. And a bunch of the electrons will orbit around the nucleus. That is the structure of the atoms. But how empty it is. So here I'm going to give you the examples. If you try to consider the proton, which is the simplest case of the nucleus for hydrogens. Hydrogen is made of 1 protons. If the proton was the size of the ping pong ball, then the electron orbiting around the hydrogen's atoms, the size of the electrons is about the tiny speck of the size of bacteria. So ping pong ball compared with the bacteria, and the distance between the protons and the electrons is about 1 kilometer away. So if you use these ratios, you can study that even for the hydrogens, the simplest atoms, how empty the structure it is. So which means for the 1 proton and the 1 electrons, there's nothing in between them. And the space they occupy, basically you can consider it is 1 kilometer if you treat the proton is the size of ping pong ball. So think about that structures, how empty it could be. And now let me give you a sense of feeling using the table we already shown at the very beginning of the semester about how big the size of the structure of the atoms. So the simplest atom is hydrogens. It is just about 10 to negative 10 meter. So this is a very standard unit for the atom. But now I'm not sure, are you surprised by that, how small it could be? And the nucleus of the hydrogens is the size of 10 to negative 14. So now you can see that how small the particles we are dealing with now. And finally, the nucleus is made of protons. The size of a proton is 10 to negative 15. So if you have a good sense of feelings using the scientific notation, let's use the football field as the most common example in our daily life. It is 9 times 10 to power of 1. You can say it is 10 to power of 2. So now you can have a sense of feeling how small the atom is, and nucleus and the diameters. So that's the reason I say that the atoms are very old and empty. So now this is the second conceptual quiz. So which of the following are incorrect? So this one I'm going to provide you the answers. The answer is that the atoms are manufactured in the planet and in the humans during the pregnancy. The answer is wrong. So the atoms is already there. So when the mothers are in the pregnancy, they don't produce particles. They just eat and using the other part of their body to form the baby. So the atom is still there. And people may be confused about why this sentence is wrong. Atoms are manufactured in the planet. So I'm not going to teach you the astrophysics, but when we're talking about the planet is not a star. So the Earth, the Mars is a planet, and the Sun is a star. And the main difference between the stars and the planet is the Sun has a nuclear fusion inside the core, so they can produce the light. So therefore, there's a possibility to form the atoms inside the core of the stars. But for the planet, they don't produce and manufacture, for example, hydrogen or the heliums. So only the star can manufacture the element. That's the reason here I say that the element heavier than hydrogen and much of helium was produced inside the interior of the stars, not by the planet. So this is very important. So now I'm going to define several important keywords we're going to use frequently in these chapters. So what is the element? Element is a material made of the same kind of atoms. So for example, it is made of the gold atoms only, or it is made of the nitrogen only, or the carbon only. So in our daily life, the gold is made of Au atoms. So if you try to divide the gold into tinier structures, all the thing you're going to see is only the Au atoms. You are not going to find out the nitrogen or carbon inside the gold. And when you are taking a note right now, the pencil actually, it is made of the carbon. So when you try to divide them into a tiny component, once again, you are not going to find out the gold there. So when the material is made of the same atoms, we say it is an element. So the other language is that atoms is an element is a lot of the same atoms. Okay? The same atoms. So therefore, now we have to define what is the atom now. it is a fundamental unit for the element. So now in the future, when people mention the element and the atoms, now you can start to build your sense of understanding what is the main difference between them. Now let's try to study. So the concept of elements, you can consider it is a microscopic quantities. So it is something you can see, can be visualized. So you can see the golden bar, you can see the nitrogen gas, you can see the pencils. This is the microscopic structure of quantities. However, the atoms is the thing you cannot see through your naked eyes. You have to use different kind of instrument to see that. This is the sub-microscopic one. So this cannot be seen, even though all the element is made of the same things. So this is reason how in the physics or in the chemistry, how we study the properties of the atoms. We can test the interaction using the different elements and see that what is the response and the products. And we can refer back what is the interaction properties for the atoms. So now we have introduced you about what is atoms and the elements. So for the atoms, they made up all the materials around us. Your body, the table, the desk, the laptop, the computer, everything. So far, based on the human understanding, there are 115 different kind of atoms. So 90 out of them can be found in the natures. The remainder was just synthesized in the laboratories. Okay, so keep this in mind. So we have 115 different kind of one, and this one actually can be made of the periodic table we are going to discuss later. So now you know that there are many different kind of atoms in our daily life, and the element is only made of one type of atoms. So now I'm going to give you some examples about the protons. What is the protons? So proton is a particle carrying the positive charge, but the magnitude of the charge is the same as the electrons. However, they are 1800 times much heavier than the electrons. And within the atoms, if you have, for example, 5 protons in the nucleus, you also have 5 electrons orbiting around the nucleus. So the number of the protons and electrons are the same in the atoms. Okay, this is a very key word. This number is the same only in the atoms. And that's the reason I say electrically neutral atoms.